Greetings and salutations, boys. This is a video to help you be more efficient in your buoyancy lab. Your buoyancy lab is designed to help you understand mass, volume, density, and the actual forces involved in Archimedes' principle and buoyancy. Gentlemen, I'm going to start out with a very simple task. My first task is going to be finding the density of water. So what I need is a graduated cylinder and a scale. I have both instruments here. I will place my empty graduated cylinder onto the scale. I want to zero that scale so that the vessel does not register, because I only want the mass of the water, not the mass of the graduated cylinder. I will then put a certain amount of water in the graduated cylinder. It does not matter how much. The density of water does not depend on the volume, so how much does not technically matter. Place it back on the scale that's already been zeroed for the graduated cylinder, and if I write down the volume and the mass of my water, then I can calculate density. And that is exactly how quick and how fast that process should go, gentlemen. Density of water, very simple, quick, fast. Our next step is to measure the actual volume and mass of our clay, the volume and mass of our clay. Now, gentlemen, typically the clay that I have provided for you in my classroom is approximately 26 grams, as shown here. Okay, may or may not be able to read that scale. That's on purpose. Gentlemen, the volume of this needs to be determined. We're going to determine that using displacement. So I have a displacement tank. So the way that we utilize a displacement tank, gentlemen, is that the very first thing we do is make sure we don't make a giant mess. Although messes are fun, we're not going to do it on purpose. So first thing we got to do is make a displacement tank overflow. All right, we always want to make a displacement tank overflow to use it properly. If it is not overflowing, then you are not using it properly. So let it overflow. Oh, we've got some dripping. If you get dripping like this, now we're not doing a measurement, so this isn't going to mess up anything, but a way to make this always work more efficiently, gentlemen, is if you dry off that spout between measurements, which we're currently doing, right? So we're about to do it. So if you dry that off a little bit, okay, between runs, it will help you actually do this a little bit more efficiently, okay? Now, since I messed with that, it probably needs a little bit more overflow, so I'm going to overflow it again. See, that helps with the dripping a little bit. We do want to make sure it overflows. But wipe that nozzle if you're having issues. It should decrease the amount of dripping and how much water you lose in the process. So now we're getting a little bit smoother process here if we dry off that spout. Okay, let's see how it becomes a little bit smoother. That's good. Okay, making a little mess on the table, no big deal. Okay, you can do this inside the sink if you want to decrease your overall messiness there. All right, I'm taking an empty vessel. My vessel is currently empty, not perfectly dry, but empty. I'm going to place it there. I'm going to place my clay inside the displacement tank. I'm going to place my clay inside the displacement tank. Here's my clay. Okay, we already measured the mass of it. We put it on the scale a minute ago, so I already have the mass of it, okay, of the actual clay itself. I'm going to place it in there as smoothly as possible. Can't guarantee I won't get any waves, but I want to try to decrease the amount that I get. Again, I'm going to let it overflow, wait for it to stop. And then I'm going to use the exact same method that I just used, right? That I just used for that. So what I need is I need the mass of the displaced water and the volume of the displaced water. So, hey, that's what I just did when I measured density. So I'm going to do the same technique. Empty graduated cylinder on the scale, zero scale, pour water into graduated cylinder. I write down the volume of the water, I write down the mass of the water, and therefore I have all the information I need for my ball of clay. Now, here's a little quick tip for you for not making a giant mess. Gentlemen, if I put my hand in there to get that ball of clay, I'm going to make a mess, unless I put an empty vessel there to catch all the goodies. Again, you can also put it in the sink. If you do all the work in the sink, you're probably going to make less of a mess and have less cleanup at the end of the lab. So, that overflows, but I'm prepared for that. Okay, that's part of the trick there. All right, so again, that's all overflow. I don't need that. So what I'm going to do now, boys, is I am going to overflow the tank again. Okay, so we're going to overflow. If we want to, we can again dry that spout off again real quick, just to sort of get a slightly better version of this. You can do that. Okay, overflow that tank. Okay, this is just a vessel I've got to catch it for when it overflows. All right, we got a nice overflow there. Okay. Now, the next thing we're doing, boys, is we are actually measuring the displacement of a boat. So what if we turn that clay into a boat? So this will take a little bit of skill. You'll have to make your clay into a boat. Okay. So that's primarily what you want to do. Now, part of the question is does our boat displace more water than our ball of clay? That's what Archimedes' principle is all about. It's all about displaced water. Okay. The buoyant force is equal to the weight of the displaced fluid, in this case, water. Okay. So if we take this, again, don't need this water. This is overflow water. All right. We're going to take a nice vessel. We're going to place an empty vessel. Here's my empty vessel there. I'm going to place it in there. I'm going to place my boat in there. Now, you want to be a little bit more gentle with the boat because the last thing you want to do is accidentally sink your boat. So if I place my boat in there, I get overflow. All right, oh, I'm getting a little drippage. I'm going to watch out for my dripping. Again, drying it off helped. Oh, but it didn't make it perfect. Got a little bit of overflow. All right, so now I have an amount. Ooh, class will start shortly. And again, take an empty graduated cylinder, place it on the scale, zero it out, pour in the liquid from the overflow that we just did. And gentlemen, you will have the mass and the volume of your displaced water for your boat. Gentlemen, that's how quick it takes to do all the main measurements for the Buoyancy Lab. I hope this helps make you more efficient when you do the lab yourself. All right, boys, have a good one.